we will import the Pandas library for data exploration, data cleaning and data analysis part. Import Pandas SPD. We will also import the NumPy library because we will make some array here. Import NumPy as np, and we will also use the Matplotlib library to draw some charts or bar graphs. Matplotlib.pyplot as plt, and we will also use the Seaborn library for the visualization purpose. Import Seaborn as SNS, and here we will also import a random module. This random module will be used to create some random values. Okay, we will run this and all the libraries will be imported in this Jupyter notebook. For your information, the random module provides the functions for generating the random numbers. Now we will import our dataset here. This is our dataset. In this dataset there are multiple columns, and if we see the rows, there are about 43,000 rows in this dataset. So to import the dataset, as you all know, we have to copy its path. I can copy from here also, and I can copy from properties also from here. Copy, and to import the dataset we have to use the pd.read_csv file, and here we will paste the path of the file. To remove the Unicode error, we will write a small r here like this. The command has been executed. To have a look at our dataset, this is our dataset. In this dataset we have 9 different columns and about 43,848 rows. The first column here is timestamp column. Here we have date, month and year, and it is starting from 1st January 2020 and it is till 31st December 2024, means about 4-year data is here. Here the information we have is per hour information, or so here is at 1st January 2020 1 AM what was the demand, at 2 AM what was the demand, so like this. The third column here is day of the week. These numbers 1, 2, 3 represents the Monday, Tuesday, Wednesday and all. And the fourth column is month, January, February 1 to 12. And this is the year column, 2020 till 2024. And this is the day of year, means first day of the year or second day of the year. As here we have 366, means 2024 was a leap year. And here we have the temperature record hour wise, you can see. Then we have humidity and we have the demand. So based on this data we will build a model that will predict the demand for the next day, next week or next month. Now let's check some basic informations about this dataset. And to check the information, we have the info function like this. It will show the basic information. Here it is showing that the range index are from 0 to 43847. These are the indexes 0 to 43847. By default the index starts from 0. And here are 43848 entries, or you can say records or rows. The data columns are total 9 columns. These are the columns. And it is showing non-null value counts, means how many non-null values are present in each column. In our first column we have 43848 non-null values, which is equal to our actual entries. In second column we have 43842 non-null values, which is 6 less than our actual entries, means in this column we have 6 null values or missing values. Similarly in our third column we have about 10 null or missing values. Next, it is showing the data type of each column. Our first timestamp column is of object data type here. We will convert it into datetime column, and our other columns are of float data type. Let's convert the data type of our first timestamp column to the datetime format, or consider our column timestamp equal to, and here we will use our pandas library pd. In this library we will use the toDatetime function, toDatetime, and inside this function we will pass the column name, and this is our column name. I will copy this and paste here, and when we will run this, the command has been executed. If we run the info function again to check the basic information, then you can see that the data type of timestamp column is in datetime format now. So it is simple. Next, we will set this datetime column as the index of our data frame. Here if you see, the index values are starting from 0 to 43847, and now we will change our index and our timestamp column will be changed to our index of the data frame. So let's see how. Here we will use the setIndex function on our data frame. Our data frame dot set index, and inside this function we have to write the column name which we want to choose as our index. We want to choose timestamp here like this, and we will save the result in our original data frame like this. When we will run this, the command has been executed, and if we have a look at our data frame now, you can see this timestamp column has become our index now, and the total value or the total count of column is changed from 9 to 8. Okay, here if we notice, there are 9 columns and timestamp was present here, but now here we have 8 columns and timestamp is present as our index of this data frame. Now we can use the describe function to check the summary statistics of some numerical columns like temperature, humidity and demand. So to consider a single column, we can write like this in single square brackets, but to consider more than one column, we have to write in double square brackets like this. Here we have considered 3 columns. On these columns we will use the describe function, and it will show the result. Here it is showing the count, means how many rows or records are present in this column. In temperature we have 43830, and in demand we have 43835 like this, because there are missing values in this data set that we will handle later. The mean temperature is 25 degrees Celsius, the humidity mean is 59, and similarly the mean of demand is 4999, or you can say about 5000. The standard deviation of each column, the minimum value present in each column, the minimum temperature is 3, the minimum humidity is 20, and minimum demand is here, and these are the percentiles, and these are the percentiles 25%, 50% and 75% of the values of these columns. This is the maximum value present in each column. 50 is the maximum temperature, 95 is the maximum humidity, and demand is 10,715, which is maximum here. In short, if we see, the describe function produces the summary statistics of all numerical columns. It checks for extreme outliers and large deviation, etc. And for categorical data frame, it will show a simple summary of unique values and most frequently occurring values.